Imagine waking up to like a $50,000 cloud bill because your new AI chatbot decided to summarize an entire user manual every single time a customer said hello.
Oh yeah, that is a nightmare scenario for sure.
Right. So today we're tackling the 810-110 exam, focusing on AI optimization and workflow patterns to stop you from bankrupting your company. It's 40 questions, 60 minutes, 85% to pass. Let's get you ready. First scenario up.
Sounds good. Let's do it.
So you need to lower the cost of a high-volume summarization workload. Out of these strategies, increasing temperature, expanding the context window, increasing sampling rate, or minimizing input prompt size, which one actually tackles token-based billing?
Well, my gut immediately says to, bump up the temperature. It's this classic cognitive bias where we tend to think if the model is less strict or like more creative, it somehow uses less compute power under the hood.
You'd really think so, right? But let's unpack that for a second.
Yeah, I mean, does changing how random the output is actually change the underlying billing foundation?
Nope, total trap.
Exactly. And the same goes for pumping up the sampling rate. Those just alter the output behavior.
Yeah.
The actual solution here is brutal simplicity. You just minimize your input prompt size.
Right, because at the foundational level, LLMs charge based on the units of text they process. Think of it like an old world telegram. You literally pay per word.
Oh yeah, if you want to save money, write a shorter message.
Exactly. Stop sending the AI a massive novel just to summarize a paragraph. Oh, and expanding the context window. That just sends more history, which obviously increases your token usage.
Right, yeah. But if every word costs money, how do we handle a massive ongoing conversation?
Which brings us to context window management. How do we control costs for a long-running AI chat? Do we increase the window to reduce API calls, cap the cumulative input tokens, switch to cheaper models, or try text compression algorithms?
See, my traditional IT brain instantly goes to increasing the context window.
Oh, totally. Same here.
Because in legacy systems, batching data to make fewer network requests just equals lower costs.
Yeah, that sounds perfectly logical, but for AI, it's actually a nightmare. With LLMs, larger windows just mean you're sending those massive blocks of chat history over and over with every single request.
Right, that makes sense. So the real fix here is capping the cumulative input tokens sent with each new prompt.
Precisely. It's like real-world meetings, you only bring the last 5 minutes of notes to the follow-up meeting.
Yeah, you definitely don't sit down and read the entire year's transcript every single time you enter the conference room.
No one has time for that.
Right, and tweaking algorithms or switching models, that doesn't solve that core mathematical issue of a constantly growing chat history. You just have to cap it.
But to cap those tokens automatically, your system really needs strict rules in place, right?
Yeah, and that ties right into our next concept. In an AI-powered automation workflow, what does deterministic branching actually mean?
Okay, so is it the AI using confidence scores to route data, human-in-the-loop pauses, evolving criteria, or just specific pre-programmed rules?
I see so many engineers lean toward the confidence scores on this one. Letting the neural network decide the next step just sounds like, well, cutting-edge AI.
Sure, it sounds cool, but in a business context, that's actually a disaster. We need total predictability when routing data, not an AI taking an educated guess.
Exactly. So deterministic branching means the next step follows specific, pre-programmed rules.
Spot on. Routing based on confidence scores is probabilistic. It's not deterministic. And pausing for a person to click a button.
Right. That's a human-in-the-loop pattern, not branching. You want real-world train tracks. The physical switch is hard-coded.
Yeah, it sends the train left or right based on mechanics, not based on how confident the train is feeling today.
Love the train analogy. So now that our workflow is routed predictably, let's tally up the final cloud bill.
Right, so when a practitioner is estimating the cost of a cloud-hosted LLM API, how does tokenization influence that cost?
Are we looking at flat rates, just the number of API calls, GPU runtime, or the token count per request?
Traditional developers always fall for the number of API calls here. They just expect standard REST API flat rate pricing. Send a request, pay a fraction of a cent.
But the reality is, the number of tokens completely determines the per request cost. That's the engine driving the whole thing.
Right, and don't get distracted by GPU runtime. That's a back-end infrastructure concern for the cloud provider.
Yeah, it's not a user-build metric for the API.
Okay, we made it through the exam block. Now let's connect the dots.
So if we synthesize all this, there are 4 pillars you absolutely must master for the exam. First, token-based cost optimization. keeping those inputs as lean as possible.
Right. And second is context window cost control, so your ongoing chats don't just spiral out of control.
Exactly. Third, ensuring you have deterministic branching in AI workflows for reliable routing.
And finally, deeply understanding tokenization and LLM API pricing. It all comes down to balancing the magic of AI with the cold, hard reality of engineering and budgets.
It really does. But I'll leave you with this to ponder.
Okay, hit me.
As the cost of compute drops and token costs inevitably approach zero in the future, will deterministic branching become obsolete? Or will locking down those hard-coded paths become even more critical just to guarantee safety?
Oh, wow. Predictability versus pure capability. That is a fantastic thought to leave on.
Yeah, something to think about.
Keep studying, and we'll catch you on the next deep dive.